Hello everyone, in this video I am going to discuss GATE 2017 year engineering mathematics questions for all branches questions related to the topic calculus. In particularly subtopic is maxima and minima of one variable function and two variable. I already upload the concept video in my YouTube channel. If you want to learn the concept then you can watch. Okay, I gave the concept video link in the description box. Now let's move on to the problem. The minimum value of the function f of x equal to one function is given in the interval minus 100 less than or equal to x less than or equal to 100 occurs at x equal to what value? This question is from EC department. It has 2 mark. First I find the critical point. Also I solve the equation f dash of x equal to 0. F dash of x equal to, here f of x is 1 by 3 x cube minus 3 cancel x. This is the f of x. F dash of x equal to 3x square, 3 cancel x square minus 1. I solve the equation f dash of x equal to 0. I got x square minus 1 equal to 0, that is x square equal to 1, x equal to plus or minus 1. These 2 points are critical points. The end points are minus 100 and 100. Here I find the values of x at critical points and end points. Then I got the local maximum, minimum, etc. Okay, local maximum and minimum values. F of 1 equal to 1 minus 3 is minus 2 by 3. F of minus 1, here minus 1 whole square is also 1, but minus 2 by 3, well, minus 1, so 2 by 3. Next, f of 100. F of 100 value is, substitute 100, I got 100 square is 10,000 minus 3. So highest positive value of highest. Okay, highest positive highest value is f of 100. So the maximum value occurs at 100. Okay, next minus 100. Here I substitute minus 100. This is positive, but here one minus is available, minus 100 is available. So finally I got the negative value, but this is highest because the value is 100 square and 100, though totally 100 cube. Okay, so f of minus 100 is negative highest value. So the minimum value of the function f occurs at the point 100. This is minimum value of f. So the minimum value of the function f occurs at the point x equal to minus 100. Answer is minus 100. The second problem is a rectangle has two of its corner on the x-axis and the other two on the parabola. One parabola is given. The largest area of the rectangle is dash. You have to find the largest area of the rectangle with one condition. What condition? A rectangle has two of its corner on the x-axis and other two on the parabola. So here you have to find the maximum area with one condition subject to the constraint also given. So in that place I use Lagrange multipliers methods. Here that is given. This question is from MN department. It has 2 mark. What is Lagrange multipliers method? Find the maximum and minimum values of f function subject to the constraint also given. This is g. You have to find del g not equal to 0, then only you have to find del f equal to lambda del g. This is the first step, and g equal to k. Solving these three equations we get the points. That points. Okay, evaluate f at all the points of x, y, z that result in from a. Step A. The largest of these value is the maximum value of f. The smallest is the minimum value of f. Okay, so first I take the largest area of the rectangle is the function f, because I have to find the largest area of the rectangle only. So f of x comma y equal to area of the rectangle is x into y. One side is x and another one side is y. X into y. Next, subject to the constraint is that parabola y equal to 12 minus x square. So x square plus y equal to 12. G of x comma y equal to x square plus y. Next I find del f equal to del g. Del f equal to del g. Lambda del g. Del f not That is del means gradient. Del f equal to lambda del g. What is del f? Here f is given. Y I vector dou f by dou x, that is y I vector plus x j vector equal to lambda into del g is 2x I vector plus j vector. And comparing these two vectors, I got x equal to lambda, because here j coefficient is x, here 1. Okay, lambda. So x equal to lambda and y equal to 2x lambda. Substitute x equal to lambda, I got y equal to 2 lambda square. Next, these two values x and y values in the subject to the constraint g, I find x square plus y equal to 12. This is the subject to the constraint. X square is lambda square plus y is 2 lambda square equal to 12. 3 lambda square equal to 12. So lambda square equal to 4. So lambda equal to plus or minus 2. Lambda equal to plus or minus 2. First case, lambda equal to 2, I got x equal to 2, and y equal to 8. And lambda equal to minus 2, I got x equal to minus 2, y equal to, y also lambda square. Okay, so 8. Next, I find the corner points 2 and minus 2. So the largest area is, I draw the parabola here. This is 0, 1, 2, minus 1, minus 2. I took the scale is 4 in on the x-axis, 4, 12. Minus 2, x value is minus 2. I got 12 minus 4, 8. This is the point. This is the one point. And x equal to 2, I got also 8. This is the corner points. This is the parabola. X equal to 0, I got 12. This is the parabola. This is the corner points of the rectangle. These two are the corner points of the rectangle. So the rectangle is here. It is the rectangle. So one side is here 1, 2, here 1, 2. So one side x equal to 4. The rectangle one side is x equal to 4. Another one side is y equal to 8. This value of y value is 8. So xy equal to 4 into 8 equal to 32. The final answer, largest area of the rectangle is 32. So the final answer is 32. The third problem is the function f of x equal to x cube minus 3x has a minimum at x equal to what? This question is from MT department. It has 2 marks. First I find f dash of x. So and I solve the equation f dash of x equal to 0. I got the critical point. F dash of x equal to 3x square minus 3. Next, f dash of x equal to 0 gives 3x square minus 3 equal to 0, that is 3x square equal to 3, x square equal to 1, x equal to plus or minus 1. These 2 points are critical points. So then I find the function f of x has a minimum value. So I substitute this critical point in f. I got f of 1 equal to minus 2, f of minus 1 equal to plus 2. F of minus 1 equal to plus 2. I find the minimum. So what is minimum? This is minimum. So f has a minimum value at x equal to 1. So the answer is 1. 1 is the correct answer. The fourth problem is the local minima of the function f of x equal to x square minus x power 4 in the range also given, so endpoints are also given, is located at what point? This question is from PA department. It has 2 marks. First f of x is given, then I have to find f dash of x, 2x minus 4x cube. This is f dash of x. Next I solve the equation f dash of x equal to 0. Then I got the critical points, 2x minus 4x cube equal to 0. Take it 2x outside, I got 1 minus 2x square. 1 minus 2x square. That means x equal to 0 or 1 minus 2x square equal to 0. That is x square equal to 1 by 2 x equal to plus or minus 1 by root 2. So the critical points are 0, 1 by root 2 and minus 1 by root 2. Minus 1 by root 2. Next, I find the value of f at critical point and the end points. First, x equal to 0, 1 by root 2 minus 1 by root 2 are the critical points. First I find f of 0, I got 0. F of 1 by root 2, I got 1 by 4. F of minus 1 by root 2 also 1 by 4. Similarly, f of minus 0.8 equal to positive 16 into 9 by 25 square. This is greater than 0, positive value, and greater than 0 only, because the minimum value is here, 0 is available. This is also greater than 0. F of 0.8, these two values are equal. Okay, these two values are equal. This is also greater than 0. Comparing four values, I got the minimum value is 0. Okay, at the value occurs at x equal to 0. The value is occurs at x equal to 0. So the local minima of the function f of x is located at x equal to 0 is the correct answer. Answer is option A. Option A is the correct answer. Fifth problem is the function f of x, one function is given, is increasing or decreasing in what interval. You have to check this function is increasing or decreasing in what interval. This question is from TF department. It has 2 marks. Here I use increasing and decreasing test. That is, if f dash of x greater than 0 on an interval, then f is increasing on that interval. F dash of x less than 0 on an interval, then f is decreasing on that interval. So first I find the f dash of x. F dash of x equal to 3x square minus 6x minus 9. Next I find the critical points, then only I split the intervals. Okay, the critical point is f dash of x equal to 0, that is 3 into x square minus 2x minus 3 equal to 0. 3 into this is x plus 1 into x minus 3 equal to 0. This is minus 3. Next, so the critical points are x equal to minus 1, comma 3. These two are critical points. So the intervals are interval and f dash of x increasing or decreasing. Okay. Interval is, what is interval? First minus 1 and 3 are the critical points. So the first interval is minus infinity comma minus 1. The next interval is minus 1 comma 3. The last interval is 3 comma infinity. These three intervals only increasing and decreasing on that interval. F is increasing and decreasing. Okay. Minus infinity comma minus 1. In that interval, f dash of x becomes, that is negative value of x. Okay. So I put here minus 2, then I got this is negative, this is also negative. Multiplication of 2 negative is positive. So in that interval f is increasing. Next, minus 1 comma 3, in that interval I put one values, that is minus 0 or 1 2 3 etc. 0 I substitute, this is positive, this is negative. Multiplication of positive and negative is negative, so this is, in that interval f is decreasing. Next, 3 comma infinity, interval 3 comma infinity, I substitute the positive values, then I got this is positive, this is also positive, because the highest value of 3 only I substitute the highest value of 3 only. So 4 minus 3 or 5 minus 3, this is positive, this is positive. So the multiplication of 2 positive is positive. This is increasing, f is increasing in that interval. So the function f is decreasing in that interval, minus 1 comma 3 is the correct answer. Here the only option is given, decreasing in that interval, minus 1 comma 3. So answer is option C is the correct answer. These problems are the GATE 2017 engineering mathematics questions related to the concepts maxima and minima. If you have any doubt in this topic, then you can ask in the comment section. Let me try to clarify your doubts. Thank you. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.